Hello everyone, my name is Abhishek and welcome back to my channel. So for a long time now, I wanted to test if AI coding platforms can create an application from scratch and deploy the same application to four different deployment environments. That is virtual machine, containers, Kubernetes, and serverless. In today's video, let's try one of the best AI coding assistants out there, Windsurf, and see if Windsurf can create the application and deploy the same application to all of these four environments. This is going to be ultimate DevOps test. Make sure you watch this video till the end. Now, before we get started, if you're completely new to Windsurf, you can use it as part of their Windsurf AI IDE, or you can use it as a plugin within the IDE of your choice. In today's video, we will use their Cascade feature. So we will use Cascade to deploy the application to multiple environments. However, in general, you can use Cascade to edit multiple files in your project, or maybe to add test cases to your existing project, or even to generate an application right from the scratch. Apart from Cascade, there are some cool features that Windsurf supports. My personal favorite is their deep wiki. Imagine you are working with a large code base, or maybe you're working with an open source project and you're not familiar with a particular piece of code. It can be a keyword, it can be a function, or it can be a line of code. You can use deep wiki to instantly get familiar with the code base because it helps you understand the code with multiple scenarios. It also supports code lenses. If you want to refactor the existing code or maybe add documentation to the existing code, you can use their code lenses. How do you get started with Windsurf? It's very simple. So you can just download their IDE. It supports Windows, Mac OS, as well as Linux. Just download the IDE, create an account with Windsurf, and you can get started with the free tier that they support. Perfect. So I have Windsurf IDE running on my local machine, and I also logged into it. Now I'll use their Cascade feature. It's very simple. Click on Command L or Control L. You will get access to Cascade code. This is a very powerful coding agent, and you can switch between different models that it supports. I'll provide it with a natural language prompt to generate a tic-tac-toe application. So I'll just say, generate a sample tic-tac-toe application and call it, let's say the name of the project is Abhi tic-tac-toe. We can also provide it with a programming language. Use JavaScript. Of course, if you want to go with Python or any other programming language, you can obviously go with it. Let's see. What does it say? I'll generate a sample application. Here is the to-do list. Okay, so here is the rough plan. Create the project directory structure, create HTML file, create CSS file for styling, create the JavaScript file with game logic, and finally test the application. So it initially created this directory on my local machine. For the first time, it asks you for the access. Either you can set manual approval for every command Cascade runs on your machine, or if you're comfortable with Cascade, you can just grant it with auto access. I have auto access on my machine. That's why it executed this command on my local machine. So you can see here a folder is created, HTML file is created, CSS file is also created. What is the next step? To create the JavaScript file with game logic. Okay, right now it is working on generating the JavaScript file. Finally, it will also test the application on the browser. It's awesome, right? So you have everything generated just using a simple prompt. All that you have to do is explain Cascade what exactly is your requirement. So this way you can enhance your productivity multiple times with Cascade. Okay, let's see if we have the JavaScript file ready. There you go. This is a JavaScript file, and now it started generating a README file for documentation. Now on the browser, we have Abhi's tic-tac-toe in running state. Let's quickly verify. Okay, player one, player two, player one, player two. There you go. Now let's proceed with the next steps. Let's start with deploying this application to virtual environment first. So I'll open the folder where Cascade generated the source code. Perfect. I trust the author. Now, within the same Cascade environment, one thing is that if you want to do all four environments deployment parallelly, you can also do it with Cascade. So you can just open a new conversation, a new window, and you can provide it with a different prompt. For example, we can use this window to generate the or deploy the application to EC2 instance, and we can use the other window to deploy the application onto Docker environment. And both of these things can actually go hand in hand. Anyways, we'll go step by step because it is going to be ultimate DevOps test. Okay, as first step, I will tell Cascade, create an Ubuntu EC2 instance on AWS using AWS CLI. Because I have multiple AWS CLIs on the machine, I just hinted it that use homebrain view folder. Use user data script to deploy the application on the instance. Make sure to open the security group and return public IP as well as port to access the application. So I provided a very clear prompt. Let's see if Cascade can deploy the application to the EC2 instance. Let's wait for the plan. Okay, so step one, it's going to use AWS CLI. So it's verifying if AWS CLI is available. Step two, it is working on the security group configuration. Then step three, it will work on creating the user data script. Step four, it will launch the EC2 instance. And finally, it will create or it will return back with public IP and the port of the application so that we can access the application on the browser. Great. So we have the user data script. Let's try to go through it. Meanwhile, it will continue to generate the other files. So apt-get update. First of all, it is updating the repositories. Then it installed Nginx. It enabled the Nginx service. It created a folder for our project. Then it copied the HTML file or index.html file. I hope it copied the JavaScript file as well. Perfect. It copied the CSS. It copied the JavaScript file. And finally, it is running it as a service, right? It has initialized the game when page loads. Everything looks cool. Now let's wait for the other steps. That is to launch the instance and return back to us with the public IP address. Okay, so the instance is launching. Let me extract the instance ID. It is extracting the instance ID for us. I think we are almost done. There we go. We have the instance ID as well as the instance DNS name. So we can either use the instance ID or DNS name to access the application. But here is a message. It says, let's wait for 60 seconds so that the application is in the running state on the created EC2 instance, which is absolutely fine because we are using the user data script. We can wait for 60 seconds to make sure application is in the running state. Okay, it verified using the curl command, but let's test it on our browser. So I'll use my browser. So this is the IP address 13.126.230.73, and we can see the application is in absolutely running state. So this means Windsurf can deploy the application onto the EC2 instance and it can get it in complete working state. We have all the files and now we also have user data.sh. Now let's move to step 2. Now that we have successfully deployed the application onto the virtual environment, let's try to do it on the container environment. So again, I'll use the same chat experience and I'll ask it to generate a Docker compose file So this time I'll ask you to generate a Docker Compose file to deploy this application as containers on the local host. Here is the plan. Create Docker file for the application, create Docker Compose file, create Nginx configuration for the container, test Docker Compose deployment. It is also testing it. Finally, create documentation. There you go. It created the Docker file. So this is the Docker file. Okay. So it is using Nginx as a base image, which is good. Here is the label. So it just set the maintainer label description. It is removing any default Nginx website. Then it copied the index.html, style.css. It copied the script.js, and also it has updated the Nginx configuration. And in the command or in the entry point, we have Nginx service running. Now this is good enough. I think this should have our application running as in container, but I'm more interested in the Docker Compose because this is slightly complicated and I want to have the container running with volume. I want to have it running with the health check and also with networking. So it set up a bridge network, which is great. It also set up a Redis data volume, also Prometheus data volume. So for the container environment, it decided to go with configuring monitoring as well, along with running the application, which is awesome. So we have 4 containers here. One is the tic-tac-toe container, which is our actual container. Then we have Nginx container, Redis container, and also the monitoring container for observability. Okay, let's see if this is in working state. It just executed Docker Compose and it is verifying if all the containers are in the running state. So it started building the containers. Perfect. Container is now running and healthy. So this is the application container. It is also verifying the health check through Nginx load balancer container. So this step is also done. Test Docker Compose deployment. It is proceeding with generating the documentation, but let's verify from our side. There you go. So on localhost 8080, I have the Abhi's tic-tac-toe application in running state. Perfect. So this confirms Windsurf can also deploy the application to local container environment, or it can deploy the application using Docker on the local machine. Now let's go to the third step. We will deploy this application. So we will ask Cascade to generate Kubernetes manifest for this application and deploy this application onto a local Kubernetes cluster. So I have kind on this machine. So I'll just create a Kubernetes cluster, kind create cluster -- name. I'll just call it Cascade. In fact, I can do the same thing through Cascade as well. I can ask it to find kind executable and create this cluster. Anyways, so I have the cluster. I have kubectl as well. If I just run kubectl get nodes. So kubectl is configured to this cluster. Okay, let's go back to Cascade. So now I'll ask it, generate Kubernetes manifest for this application and deploy the manifest to Kubernetes cluster that is configured with kubectl. You can find kubectl at homebrew bin folder. I mean, the reason why I'm pointing it to the executable, because on this machine, I have 2 versions of kubectl. So that's why I'm just pointing it to the right kubectl. Let's look at the plan. First step, verify the kubectl installation. Second, it is going to create the namespace for us. It's going to create config map for Nginx configuration. Awesome. Create deployment manifest, service manifest. It is also creating ingress, which is optional. However, because this is a local Kubernetes cluster, we will just use kubectl port forward. Finally, deploy these manifests to Kubernetes and verify using the deployment, or just get the access URL and return it back to the user. That is us. Okay, it generated the manifest namespace.yaml. Let's see. API version v1 kind namespace. This is going to be the namespace tic-tac-toe. Okay, then it generated config map. It generated config map assets. This config map is going to hold the Nginx configuration. We can also verify that. If I open config map.yaml, so we can see the complete Nginx configuration. Listens on port 80, server name is localhost, and all other defaults. Great. So it has created all the configuration files. Now it started deploying the manifest to the Kubernetes cluster. Most of the manifests are created. We can also verify. If I just run kubectl get ns, I should see tic-tac-toe namespace. And within the tic-tac-toe namespace, I'll just run kubectl get all -n tic-tac-toe. Okay, we see some pods in crash loop back off. Let's try to see what is the reason for it. Kubectl logs. Okay, let's verify -n tic-tac-toe. Tic-tac-toe. Okay, it says permission denied. So this is the reason why we have the pods in crash loop back off. Let's see if, oh, awesome. So it already figured out the issue. So you can see here pods are crashing. Let's check the logs to see what is the error. And it tried to fix the issue as well. So it updated the deployment configuration with changes, and it started redeploying the pods, or it started to restart the pods. Let's verify it from our end as well. Kubectl get pods -n tic-tac-toe. Okay, now the pods are moving to the running state, but let's be little more careful. Let's watch it for few more seconds. Great. Now the pods are in the running state. This is awesome. So during the deployment, it encountered an issue without any human intervention. It understood what is the issue, and it also fixed the issue by itself. So it says, excellent. Now the pods are in the running state and all the pods are looking great. Okay, try to connect on the local host port. Of course, that's not possible because I'm using a kind environment. So it decided to use port forwarding. Something that I wanted to do it myself. I wanted to use kubectl port forward, but Cascade realized that I'm using a kind environment or a local Kubernetes environment. So instead of going with ingress, it chose a different path, that is kubectl port forward. Imagine how intelligent is it, right? So it says you can now access the application on port 8081. Let's try it. So this time, again, I'll take my browser, and on localhost 8081, I will try to access the application. Now, this is quite impressive because these issues would have taken a lot of time, especially the Nginx error. Probably if we have to look at this issue, if we have to understand what went wrong with the Nginx user configuration, definitely we would have taken a lot of time. But Cascade, with its knowledge base, it figured out the issue. It instantly updated the deployment manifest, and it also fixed the issues by itself. Now let's move to step 4, the final step. Let's see if Cascade can also deploy this application onto serverless environment. We will use AWS Lambda functions. So I will write a prompt. Deploy this application onto AWS Lambda or AWS Lambda function. I'll just hint it, use AWS CLI from homebrew/bin. In your case, this might not be needed. Again, I'm repeating, I have duplicate installations on my machine because I use these installations for different use cases. So that's why this is my prompt. Deploy the application onto AWS Lambda functions using AWS CLI from homebrew bin. That's all. I'm not providing it with any additional information. This time, let's see if it can deploy the application onto the serverless environment. So this is the plan for the last step. So it says check AWS CLI, create Lambda function handler, create deployment script, create IAM role for Lambda, deploy the Lambda function, and also create API gateway for web access. Imagine how complicated are these steps, and it is going to do all of that for us. Okay, Cascade created a new folder for Lambda. Okay, within the new folder, it created the JavaScript file. It also created the package.json. I believe it is also going to create Lambda handlers and the deployment script. Now, we started with a very simple application. Look at the source code at this point. It has observability setup. It has a README file. It has Docker Compose file. It has Kubernetes manifest. Now we also have the serverless related manifests. So it is working on deploy.sh. I believe it's going to add a bunch of AWS CLI commands to it. Create IAM role for Lambda. Okay, accept all. Let me run the deployment script. So it's going to run the deployment.sh. Once the deployment.sh is done, I believe we should have Lambda function. Cascade is working on it. Let's head to the AWS console and see if the Lambda function is created. Okay, so we have the Lambda function created just 2 minutes ago. By now, it must have updated the Lambda function configuration. It must have updated the handler as well. Let's see what does it say. Excellent, health check is working. It tested the health check with curl. And it also verified, it also verified the application, and application is in working state. This is awesome. So we have got the Lambda function also working with Cascade. We can also verify it. So I'll just head to this function. I will click on the test. We have API gateway. Great. So we have the application also running on the Lambda. So it says powered by AWS Lambda. So Windsurf passed their ultimate DevOps test. It was able to deploy the application to 4 different environments. We have the application running now on AWS EC2. We have the same application running as container. We have the application running on Kubernetes. Also, we have the application running in serverless architecture using AWS Lambda as well as API gateway. So this is the ultimate test. Isn't it awesome? Without Windsurf, we would have taken at least 7 to 8 hours to get this running, probably with the help of Google or by browsing through resources on the internet. But with Windsurf, we can actually do it in 20 to 30 minutes. So this shows we can enhance our productivity multiple times by using Windsurf and their Cascade coding agent. There are so many other features that Windsurf supports. So I would highly encourage you to try Windsurf. I'll share all the relevant links in the description so that you can get started with Windsurf today. See you all in the next video. Take care.